gang, so this is page 10 of the packet. This is the last page we've got. All right, so let's do the zero product rule. So that just means we want to take these and we want to find the solutions. We want to know the x-intercepts and the zeros. And remember, x-intercepts and zeros are the same thing. We also want to put it in standard form. I'm going to do standard form last. Whenever you want to know the zeros, a couple of things we could do. One is we could just simply graph it. We could just say y equals, we could do parentheses x minus 3, parenthesis x minus 4, graph it, and we could see it right there. So let me zoom standard. I had some weird zooms on there. So I can see the x-intercepts are right here and here. If I wanted to verify that, oh, hello. Let's go here. I look for the doubles, and I can see them right there. And see how it's honing in right here? I can't see the vertex, but I can see that both of 3, 0 and 4, 0, those are my zeros where it crosses. How do you do it algebraically? You take x minus 3, set it equal to 0, and x minus 4, set it equal to 0. Solve this. This would give me x equals 3. This would give me x equals 4, which is exactly what I saw over here. So the intercepts, I'm going to say, are at 3, 0, and at 4, 0. The zeros are at 3 and 4. Standard form, though, how am I going to do that? So I need to multiply this, that double distribute that we did earlier. So we're going to do, remember we cover up the negative 3, and we're going to do 2 across the top. X times x will be x squared. X times negative 4 will be negative 4x. And then we're going to go the other way. Negative 3 times x would be negative 3x, and negative 3 times negative 4 would be positive 12. In the middle, it always adds together. So x squared minus 7x plus 12. So x squared minus 7x plus 12. All right, I'm going to let you do the other one. And you're going to be like, wait, what about that 2? Well, remember the 2 is not really going to matter, because you're going to set each of these equal to 0. And so if I did 2x plus 1 equals 0, and then x minus 4 equals 0, you're going to divide both sides by 2, and that 2 is going to go away. So you're going to end up with x plus 1 equals 0. So anytime you have a number in the front, when you're trying to solve for the solution, you don't have to worry about it. So this will give me x equals negative 1, and this will give me x equals 4. My x-intercepts are at negative 1, 0, and 4, 0. My 0 is the same thing, negative 1 and 4. But when you go to do your standard form, the 2 is going to stay put. So we're going to do x plus 1 times x minus 4. I wasn't going to do this one, and now I am. I'm going to keep the 2 till the very end, so he's just going to come down. 2 across the top. X squared negative 4x, 1 times x plus 1x, and 1 times negative 4 is negative 4. I'm holding off on that 2 till the very end. Always in the middle, they go together. So 2 parenthesis x squared minus 3x minus 4. The very last thing I'm going to do is take that 2 and multiply it all the way across, hippity hop across the top. 2 times x squared would be 2x squared. 2 times negative 3 would be negative 6x. 2 times negative 4 would be negative 8. All right. Now we're to this one. Same thing. We want standard form, x-intercepts, and zeros. Same exact same thing you just did. So maybe you're like, well, that one looks a little bit different. Not really. Negative 2 parentheses x minus 4 squared. I'm going to graph it just so we can see what it looks like. Oh, it only touches once. Well, that kind of makes sense. This right here, I would write y equals negative 2 times x minus 4 squared. That means that whole chunk 2 times. And when you look at it this way, you're like, oh yeah, I would set it equal to 0 to find the zeros. So the 2 would go away because it would absorb into there, and I would have the same thing. X minus 4 equals 0, and x minus 4. It's the same thing. So basically, x equals 4. That's the only 0 I have. So x-intercepts are at 4, 0, and the zeros are at 4. Standard form, though, I'm going to have to remember I've got to expand it out. So I need to multiply all this, just like I did up here, and at the very end, take that -2 across. All right. You can pause your video and do that. I'm going to work on this next one. All right, so on this one looks a little different. So I'm going to go to y equals. I'm going to do x times x minus 2 plus 3 parenthesis x minus 2 again. Because maybe this one you're like, I can't quite tell that one. Oh, okay. I've got one at -3 and one at +2. So I know my x-intercepts are at -3, 0, and +2, 0, which means I've got -3 and 2. But can you show me algebraically how to do that? X minus 2 and x minus 2, it's the same in each of these. So what I do is I pull x minus 2 to the front, and then I look at what is left. When I take x minus 2 out of this, when I take this away, I'm left with x. And when I take x minus 2 away from this one, I'm left with +3. Okay, well, here we go. You're going to set that equal to 0, which means you've got x minus 2 equals 0 or x plus 3 equals 0. This would give me x equals 2. This would give me x equals -3. Oh, that's what I got. Now, take this and distribute it, and that'll give you your standard form. X times 3, -2 times x, -2 times 3. All right, number 8. Pause your video if you need to and go back and work that one and then continue on. A soccer ball is kicked from the ground level. So I'm going to just kind of think about a picture here. A soccer ball is kicked from the ground level. The function y equals -16x times x minus 2 gives the height in feet of the ball. While the ball, after how many seconds will the ball hit the ground? So basically this football's been kicked up and then it's landed. And so it wants to know how long was it in the air. Use your graphing calculator to verify your answer. So this shouldn't be that hard. So y equals -16x times x minus 2. All right, so here we go. Y equals -16x times x minus 2. I'm going to graph it. And you wouldn't expect the football to be in the air for 20 minutes or anything like that. I mean, use your common sense here. We're going to kick it up. It's going to come down. It's not going to be in the air very long. And if you look right here, it looks like it's only in the air about 2 seconds. So how did they get that? How did they get it algebraically? I can see it on my graphing calculator, but how do I get it mathematically? Well, it's the same thing. What goes up, it's got to come down. I want to know, when does it equal 0? When does the y value, this is x comma y, that ordered pair right there is x comma 0. When does the y value equal 0? So -16x times x minus 2. You set each one of these equal to 0. So -16x equals 0. Well, that would give me x equals 0. That's this one right here. We already know that one. I want to know this one right here. So I would say x minus 2 equals 0. And I get x equals 2. So that means in 2 seconds. We verified it with our graphing calculator and we got it right. All right, so here we go. A tennis ball is tossed upward. So we're down here, tossed upward from a balcony. The height of the ball is modeled by this function here, where x is the time in seconds after the ball is released. Find the maximum height of the ball at the time it takes the ball to reach the height. Graph the function to determine approximately how long it will take the ball to hit the ground. Well, they didn't say we had to do anything on this one, really, so we're just going to plug it in our calculator. -4 parenthesis x plus 1, x minus 3. We're going to graph it. Remember, it's probably not going to be in the air super long. So you're up, and you notice how it's over here negative, and time can't be negative, and this is time. So you've got this balcony, and you're up here, and you're tossing the ball down. How long is it in the air? So what I'm going to do is go to second table. I'm going to look and see, can I see the vertex of this? And I cannot. I'm not seeing it anywhere. But I do see that at 0, I'm at 12. So I'm going to go ahead and put that on here. Oh, and it doesn't go up. 1, 2, 3, 4, 9, 10, 11, 12. I'm just going to put it right there. And I notice that as it comes down at 3, 0, seems to be when it hits the ground. So I'm going to try and okay, that either my pen's dying or something. It didn't like doing that. But okay, I probably drew it wrong. I kind of drew it coming straight down like that, but does it go up and then come down? And if you look, it sure does. Look at that at 0, 12. I should probably go up the other way, shouldn't I? Oh, look at that. Can you see the vertex right there? 0, 0, 12, 12, 16. So 1, 16. Oh yeah, my graph isn't good at all. We'll just pretend like it's not there. So 12, so 16 would be up here. So 1, so it actually goes up and then comes down. Oh, why my pen's not wanting to do that? It doesn't like this piece of paper right there. So it looks something like that. So one of the questions it says is find the maximum height of the ball. Well, the ball goes up at 116. That's the vertex. And then it wants to know, graph the function, which we sort of did. And we want to determine how long until the ball hits the ground. Well, it hits the ground at 3 seconds. And I think that was all it asked. Yeah, find the maximum height of the ball. So there we go. We got our vertex and we got the seconds.